Okay, with all these fractions around, we have a very important question to consider, and that is, how can we tell whether two fractions are equivalent? For example, let's say we're looking at 7/28 and 16/64. Well, I happen to know, because I made these up, that 7/28 is equivalent to 1/4, and 16/64 is equivalent to 1/4. So all three of these mark the same point on the number line. These two fractions are in fact equivalent. And notice how we did that. We said that 7/28 and 16/64 were equivalent because we knew they were equivalent to the same thing. So that gives us a way to say that two fractions are equivalent, but it doesn't necessarily give us a way to say that two fractions are not equivalent. How can we say that two fractions are not equivalent? Maybe they're both equivalent to the same thing, and we're just not clever enough to figure out what. Well, it turns out that the way that we always handle this problem, whenever we have things that can be written in a whole lot of ways, we'd come up with a standard way of writing something, and then to decide whether two things are equivalent to each other, we write them both in the standard way and see if it's the same. There are other ways of checking whether things are equivalent, but this method comes up over and over again, and it always works. In particular, this tells us for sure if things are not equivalent to each other. This is a really cool move, and it's a move that we're going to be making over and over and over again for pretty much the rest of our career in mathematics, which is one of the big reasons we make such a big deal out of doing it to fractions. Because fractions are kind of the simplest sort of object that we might want to make this move on. Fractions are the simplest sort of object that can be written in more than one way. So for fractions, the standard way of writing them is called lowest terms. In lowest terms, the numerator and denominator have no factors in common. Let's recall, what's a factor? Let's think about the multiplication sentence, 3 times 7 equals 21. Looking at this multiplication sentence, we see that 3 is a factor of 21, since there is a number that we can multiply by 3 in order to get 21. From the same sentence, we say that 21 is a multiple of 3 for the same reason, right? So to say 3 is a factor of 21, or 21 is a multiple of 3, these are different ways of describing the same fact. Now, I was a little bit sloppy here. I just said there is a number. What I meant is there is an integer. It has to be an integer. We'll see shortly that if we just say there is a number, this sentence doesn't tell us anything very interesting at all. So there is an integer such that 3 times that integer is 21. A couple of other facts that I want you to recall that you've seen in previous math classes. Any whole number, 2 or more, can be factored uniquely into prime numbers, numbers whose only factors are themselves and 1. There are several ways we can make that happen, but the easiest way is with what's called a factor tree. So let's say I wanted to factor 30 into primes. Well, 30 is 3 times 10. 3 is prime. 10 is 2 times 5. 2 and 5 are prime. You should know that 2, 3, 5, 7, 11, and 13 are prime. You should also know that any number less than 100 either is prime or has one of these as a factor. So based on that knowledge then, how can we write a fraction in lowest terms? Now again, there are other methods for doing this, but this method is straightforward and always works. First we factor the numerator and denominator into primes, then we cross off pairs of common factors, and finally we multiply the primes that remain. There are other methods of doing this, but we are going to practice this one because later on we're going to do the same thing with expressions containing variables, at which point this will be the method that we want. So let's try an example. Let's say we want to write the fraction 84/90ths in lowest terms. So let's see. 84, well this is an even number, so it has 2 as a factor. To find the other factor, I'm going to use my calculator to take 84 divided by 2 is 42. 2 is prime. 42, well that's still even, it has 2 as a factor. 42 divided by 2 is 21. And 21, I happen to know, is 3 times 7. If I didn't know that, I could go through that list I gave you. 2, 3, 5, 7, 11, 13, and try dividing by each of those. Okay, so that's 84 fully factored. 90, well that's 9 times 10. 9 is 3 times 3. 10 is 2 times 5. Notice if the last digit is 0, then 10 is a factor, and that is always the easiest way to start factoring. Okay, so I've factored my numerator and denominator into primes. 84/90ths is 2 times 2 times 3 times 7. Right, those are the factors of my 84 over 3 times 3 times 2 times 5. Now I want to cross off pairs that I see in common. So I see a 2 in both the numerator and the denominator. I don't see another 2 in the denominator. I'm out of 2's. But I see a 3 in both the numerator and the denominator. I don't see a 7 in the denominator. That's it. The only factors that are left in the numerator are 2 and 7. In the denominator are 3 and 5. So my last step is to do that multiplication. 2 times 7 is 14. 3 times 5 is 15. So 84/90ths is 14/15 in lowest terms. This process of taking a fraction and writing it in lowest terms, or as we'll see more generally, of taking any way of describing a number and writing it in its standard form, is called simplifying. So instead of write 84/90ths in lowest terms, simplify 84/90ths fully. This fully just means all the way to lowest terms, right? Rather than, for example, just canceling out the 2's and leaving the 3's sitting around.